Okay, today we got another problem from Leetcode 150, missing like 10 problems, 647 palindromic substrings, return number of palindromic substrings. Well, depends on the constraints, because doing like a ON solution would be tough. And square solution should be pretty easy. Because, you know, we could technically do n log n, because like let's say we can calculate substrings hash, which we can do with rolling hash, right? And then if palindrome is this and this is a palindrome, all right, if we have palindrome of length 12, then there is also palindrome of 10, 8, blah blah blah. So, and no more are palindromes. So technically we could binary search at each position, right, the length of the palindrome starting at that position, and do it twice, because palindromes can be even or odd length, and check in O1 using rolling hash. So theoretically you can do n log n solution, but who cares about that? So let's do this simple one. Let's do like n, right? And now left, right, I, or we could like count pals from I, and now if I plus 1 and like that. Okay, and now while SL, SR, so basically we just expand from each position or each adjacent pairs of position. So we'll say that ans is not defined, so like non-local ans. It should work. Okay, so runtime 136. It's not that efficient. I mean, technically I could do it inline, but let's see if editorial shows us the check all substrings. What is this trying to analyze? Dynamic programming? You kidding? Yes. Okay, n log n. Fair enough. Palindromic trees. Oh my days. Holy, what is that? Oh my god. Suffix array every time. Approach free on steroids trademark. Okay. I mean, yeah. Build suffix trees for input and it's subsequently click LC. Okay, so let's say you put all in the same one. There was some proof, we did this in school, but I have no clue anymore. see this dynamic programming. I mean, yeah, I guess dpij and then fair enough, and then I mean, yeah, it's pretty straightforward, but fair enough. Okay, I mean, I hope when I finish this list I go to something more difficult, because these medium problems are stupidly easy. Expanding around centers. Intuition. Odd length palindromes have a single center, and even length palindromes have two-letter centers. We try all centers, of which there are ON, and try to expand until we can, counting each possible palindrome. Note, I guess I can add that here. Okay, let's do time complexity. So ON squared, where n is the size of this string, since we try ON centers and expand each of them at most ON times O1, since we only have to use a couple of extra variables. Note 1, we can one might notice that answers to question, is this a palindrome, when asking about expanding substring, are monotonic, i.e. they are first true for some number of expansions and then false for the rest of them. If a substring is not a palindrome, it cannot become one by adding elements to its sides. Okay. If okay, so experienced readers probably already know, when you have monotonic answers, use binary search. Only thing we would need to answer in O1 is if the halves of the substring are equal to their, if the first half of the substring is equal to the reversed second half of the substring, which we can answer in O1 with rolling hash. Okay. Note 2, Manaher's algorithm improves this improves the rolling hash algorithm to ON time complexity. Okay, goodbye.